I need to tell you something that's going to sound crazy at first, but once you see it, you can't unsee it. Everything you've been told about the speed of light is a lie. Not a malicious lie, but a lie of convenience, a lie of history. We call it the speed of light because light was the first thing we caught moving at this speed. But here's the truth. Light has nothing to do with it. The speed we call c 299,792,458 meters per second isn't the speed of light. Light is just a passenger on a cosmic speed limit that would exist whether light existed or not. If we lived in a universe where photons never came into being, where light was somehow forbidden by the laws of physics, c would still be there, lurking in the equations, governing everything. So what is it really? It's the speed of causality. It's the speed at which cause and effect can propagate through the universe. It's the speed of information itself, the speed at which reality can communicate with itself. Light just happens to be massless, and anything massless is forced by the structure of space-time to travel at exactly this speed. Light doesn't choose to go this fast. It has no choice. It's not special. Gravity moves at this speed. Changes in electric fields move at this speed. If you could somehow wiggle a magnetic field over here, the wiggle would propagate over there at exactly c. No faster, no slower. Let me show you why this matters with a thought experiment. Imagine I have a magic button, a terrible cosmic delete button. And when I press this button, the sun vanishes. Not explodes, that's too slow, too physical. I mean vanishes. Every atom, every photon inside it, gone, deleted from existence instantaneously. Now, I press it, right now. The sun is gone. What happens to you, standing here on Earth? You might think, immediate darkness, immediate cold. The sky goes black and we freeze. But that's not what happens. Not immediately. Because you're 8 light minutes away from the Sunday. And for the next 8 minutes, you have no idea anything has changed. The sky is still blue. You can still see the sun up there in the sky because the light that left the sun 8 minutes ago is still traveling toward you. It's in transit. Those photons don't know their source has been destroyed. They just keep moving at sea, oblivious, carrying the image of a sun that no longer exists. So for 8 minutes, you're looking at a ghost. You're basking in the warmth of light that's now a lie. But here's the truly disturbing part, the part that reveals what C really is. Gravity is still pulling you. Earth doesn't fly off into the void. It keeps orbiting. Not around the sun is gone, but around the ghost of where the sun used to be. Because gravity, like light, travels at sea. The information the sun is gone hasn't reached us yet. Think about how eerie this is. For 8 full minutes, we are orbiting nothing. We are held in place by a force emanating from a source that no longer exists. The gravitational field lines, stretched across 150 million kilometers of space, still pull on Earth because they don't know they should stop. They haven't received the memo. And that memo travels at sea. And then, 8 minutes after I press the button, everything changes at once. The light shuts off. The sky goes black. And simultaneously, not a microsecond, before or after Earth stops feeling the sun's gravity, the planet lurches forward in a straight line, following Newton's first law, coasting into the cosmic darkness at 30 kilometers per second. We're flung into interstellar space, and in that terrible moment we finally learn the truth. The sun has been dead for 8 minutes, and we've been living in the past. This is what C really is. It's not about light. It's about how fast reality can update. It's the speed at which the universe can say, hey, something changed over here, and tell the rest of existence about it. Light just gave us a way to measure it. So now you're wondering, why? Why does this speed limit exist at all? Why is it 299,792,458 meters per second and not some other number? Why isn't it infinite? Who or what decided this? The answer is one of the most beautiful discoveries in physics, and it came from a man named James Clerk Maxwell in the 1,860 seconds. Maxwell wasn't trying to measure the speed of light. He was trying to understand electricity and magnetism, two forces that seemed completely separate. People knew about electric charges and magnetic poles, but Maxwell saw something deeper. He saw that electricity and magnetism were two sides of the same coin, two aspects of one unified force. He wrote down 4 equations, just 4, that described everything about how electric and magnetic fields behave, how charges create electric fields, how moving charges create magnetic fields, how changing magnetic fields create electric fields. These equations were elegant and complete, a perfect mathematical description of electromagnetism. But when Maxwell sat down and played with these equations, something strange fell out. He found that if you wiggled an electric field, it would create a magnetic field, and that changing magnetic field would create an electric field, and that new electric field would create another magnetic field. Back and forth, electric and magnetic, magnetic and electric, and the whole disturbance would propagate outward as a wave, an electromagnetic wave. And when Maxwell calculated how fast this wave should move, he found something shocking. The speed depended on two numbers, two fundamental properties of empty space itself. One was called the permeability of free space, often written as mu0 or mu0. This measures how easy it is to create a magnetic field in a vacuum. The other was called the permittivity of free space, often written as epsilon0 or epsilon0. This measures how easy it is to create an electric field in a vacuum. These weren't arbitrary numbers. They could be measured in a lab. And when Maxwell took these two numbers and combined them in a very specific way, one divided by the square root of their product, out popped a speed. A specific, finite speed. And when he calculated the numerical value, he froze, because the number he got was 310 million meters per second. With an experimental error, this was the speed of light. Maxwell realized in that moment what light was. Light wasn't some mysterious substance flowing through space. Light was an electromagnetic wave, a self-propagating ripple in electric and magnetic fields. And the speed of light wasn't some separate cosmic speed limit, it was a direct consequence of the properties of space itself. The speed fell out of the structure of the vacuum. But let's dig deeper into what this means. What are mu0 and epsilon0 really telling us? Think about it this way. Imagine space is like a medium, like a material. Not a physical material, there's no ether or substance, but space still has properties. It resists certain changes. It has, in a sense, a stiffness. Here's an analogy. Imagine you have a bowl of Jell-O. If you tap the surface gently, a wave ripples through it. How fast does that wave move? It depends on how stiff the Jell-O is. If the Jell-O is soft and jiggly, waves move slowly. If it's firm and rigid, waves move faster. The stiffer the medium, the faster the wave. Now imagine, instead of Jell-O, you have a steel rod. Tap one end, and a compression wave shoots down the rod to the other end, much faster than in Jell-O. Why? Because steel is stiffer. It resists deformation more strongly, and that resistance actually makes waves propagate faster. Space is like this. The vacuum isn't empty in the philosophical sense. It has structure. It has properties. The values of mu0 and epsilon0 are like the stiffness of space for electromagnetic disturbances. They tell you how much space resists the creation of fields, and the speed of light, c, is determined by this stiffness. It's the speed at which ripples in the electromagnetic field can propagate through the vacuum. And here's the kicker. It's not just electromagnetic waves that travel at c. Gravitational waves, ripples in space-time itself, also travel at c. If you took the sun and moved it, suddenly, impossible, but humor me, the change in its gravitational field would propagate outward at exactly the speed of light. Not because gravity is related to electromagnetism, it's not, but because c is more fundamental than either of them. It's woven into the structure of space-time itself. Einstein saw this. When he developed special relativity in 1905, he realized that c wasn't the speed of light at all. It was the conversion factor between space and time. It was the exchange rate, the number that tells you how much time equals how much space. In relativity, space and time aren't separate entities. They're dimensions of a single four-dimensional fabric called space-time. And c is the scaling factor that relates them. It's the cosmic constant that tells the universe how to mix space and time together. So when we measure c by measuring the speed of light, we're really measuring a property of space-time. Light is just our probe, our measuring stick. But c is space-time telling us, this is how stiff I am. This is how fast change can propagate through me. And the fact that c is finite, not infinite, means space has a non-zero stiffness. It resists change. It takes time for information to get from one place to another. And that fact, that simple fact, is about to become the most important thing in the universe. Now we get to the heart of it, the philosophical core of why c matters. Why isn't the speed infinite? Why can't information travel instantaneously across the universe? What would break if c were infinite? The answer is this: everything would break. Because if c were infinite, there would be no such thing as cause and effect. Let's think about what causation means. I do something, I push a ball, and then something else happens. The ball rolls. The push is the cause, the rolling is the effect. Cause comes before effect. That's the foundation of how we understand reality. Events have an order. A leads to B. B doesn't happen before A. But here's the subtle thing. For cause and effect to have meaning, there must be a delay between them. A cause here has to take some time to produce an effect over there. Why? Because if the effect were instantaneous, if it happened in exactly the same moment as the cause everywhere in the universe, then before and after would become meaningless. Let me show you why with another thought experiment. Imagine you and I are in two spaceships, far apart, and we're moving relative to each other. You're drifting past me at half the speed of light. Now, I snap my fingers. In my reference frame, my finger snap happens at a specific moment in time called a t equals 0. And let's say my snap causes something to happen to you. Maybe it triggers a light on your ship to turn on. If that signal traveled at the speed of light, c, then we both agree on the order of events. I snapped first, then the light turned on later. In your frame, in my frame, in anyone's frame, the cause precedes the effect. The universe maintains causal order. But what if the signal traveled faster than light? What if it were instantaneous in my frame? Here's the shocking thing. Because of how relativity mixes space and time when you're moving, what's simultaneous in my frame is not simultaneous in your frame. If I see two events happening at the same time, you, moving past me, will see one of them happen before the other. This means if I could send a signal instantaneously in my reference frame, you would see the signal arrive before I sent it. Not just a little bit before, depending on how fast you're moving, you could see the effect happen hours or days or years before the cause. And if you could send a signal back to me, also faster than light, I could receive your reply before I sent my original message. We could have a conversation where you answer my question before I ask it. I could send you information about the future, and you could change what happens to me in the past. We could create a time machine. We could create a paradox. I prevent my own existence, and yet I still acted to prevent it. The logic collapses. The universe cannot allow this. Causality is sacred. Cause must precede effect, or reality unravels into contradiction. And the only way to preserve causality in a universe where motion is relative is to have a cosmic speed limit. Nothing can travel faster than c, not even information, not even cause and effect itself. Because if it could, cause and effect would reverse for some observers, and the universe would destroy its own consistency. So c is the speed of causality. It's the speed at which causes can propagate effects. It's the speed at which information can flow. And it's finite not because the universe is slow, but because the universe must preserve the logic of time. Think of it this way. C is the cosmic frame rate. Imagine the universe is like a movie, unfolding frame by frame. Each frame is a snapshot of the entire universe at one moment in time. The maximum rate at which updates can propagate is set by c. If c were infinite, updates would be instantaneous everywhere. The concepts of before and after would lose meaning across space. But c is finite, so the universe can't be globally synchronized. Events have a structured order. There is a meaningful separation between here and there, now and later. History becomes possible. And more than that, c makes you possible. Your thoughts are causal processes. One neuron fires, which causes another to fire, which causes signals to propagate through your nervous system, which causes your body to move. If effects could precede causes, those chains would become incoherent. Consciousness would be impossible. C is the law that says the universe will make sense. Causes precede effects. Time has direction. Information flows at a finite speed. And that speed is the same for everyone, no matter how fast they're moving or where they are. It's the invariant foundation upon which the rest of physics is built. Light just happens to travel at this speed because light has no mass. But the speed itself is not about light. The speed is causality. The speed is space-time. The speed is the universe saying, this is how fast reality can happen. Now here's where it gets dark. Because c, this beautiful speed limit that preserves causality and makes the universe coherent, is also a prison. And we are trapped inside it. Light travels at c, which means it can cross vast distances, but not instantly. It takes time. Light from the sun takes 8 minutes to reach Earth. Light from the nearest star takes years. Light from the Andromeda galaxy takes about 2.5 million years. When we look at distant galaxies, we're not seeing them as they are now. We're seeing them as they were when the light left them. We are always looking into the past. But the universe is expanding, and the expansion is accelerating. Galaxies are moving away from us, and the farther away they are, the faster they recede. This isn't just motion through space. Space itself is expanding, carrying them along. And because space can expand faster than c, there are regions of the universe that are effectively rushing away from us faster than the speed at which information can catch up. Now you might think, so what? We just can't see them. But it's worse than that. Imagine a galaxy so far away that space is expanding between us and that faster than light can cross that distance. That galaxy can emit light toward us, and those photons can travel at c maximum speed. But as they move, the space they must traverse keeps increasing. It's like running on a treadmill that's moving faster than you can run. You're sprinting at your absolute limit, but the belt is dragging you backward faster than you can advance. That's what happens to the light from certain distant galaxies. The photons are moving at c, but the expanding space pulls the destination away faster than the photons can close the gap. The light never arrives. Not later, not eventually, never. This means there is a horizon, a boundary. Beyond it, galaxies are not merely unreachable by travel, they're unreachable by information. The light they emit today will never reach us, ever. No signal, no message, no influence. And this horizon isn't a philosophical idea. It has consequences. There are galaxies we can see right now whose future light will never reach us. There will be a last photon we ever receive from them. After that, they don't vanish physically, but they vanish from our causal universe. They become permanently disconnected. They could explode into supernovae. They could form new stars. They could host life. None of it will ever matter to us, because none of it can ever reach us. They are outside our causal reach. Separate, for all practical purposes, like islands slipping beyond an unbreakable fog. And we are trapped inside our own bubble of causality. We can see outward because old light is still arriving, but that view is a museum of the past. Beyond a certain distance, reality continues, but it is forever sealed off. Think about what this means for the future. Imagine a civilization trillions of years from now, living around a star in what remains gravitationally bound. When they look into the sky, what do they see? Almost nothing beyond their local group. The rest will have been carried beyond the horizon. The evidence of the larger universe will be faint or gone. They might conclude their galaxy is the entire universe. They might never discover the Big Bang because the strongest observational clues could be inaccessible or undetectable. We live in a narrow window where the universe is still visible at large scales, where the deep sky still tells a story. But that window is closing. C protects reality. It preserves causality. It gives time its order. It makes the universe logically consistent. But it also isolates us. It confines us to a local patch of space-time, beyond which we cannot go and from which we cannot receive. Light is just the messenger. C is the law. And the law is absolute.